Imagine you're in the middle of writing a paper and you can't quite find the right words to say, so you go and look in a thesaurus and find a couple words that sound better. That's reasonable, right? But imagine you're in the middle of writing a paper and you can't find the right words to say, so you create a completely new language. That's a little unreasonable and doesn't sound realistic. But what if I told you that's how rocket science works? They have to make up the math in the middle of their projects because the old math that they have isn't working to get the job done. I'm Heidi Madsen, and I'm going to be talking about how I checked out a book on anti-gravity and now I can't put it down. So I didn't actually check out a book on anti-gravity, but ever since I heard about aerospace engineering, rockets, I have not been able to get enough, and I just always want to learn more about it. I've always been super interested in the stars and the moon, and I just love looking up and admiring what God has given us to look at. So much so that I actually got a tattoo of them together behind my right ear. And I've just always admired what God has given us to look at and the numerous things that He's given us to learn through them. One of my heroes and inspirations is Katherine Johnson. She was a core member of the Space Task Group in NASA in the 1950s and 60s. She did a great deal of the calculating through analytic geometry for many of the space missions that they used, and she was the backbone of many of those missions. She constantly had to go back through and check the math because the numbers were changing daily or they had to come up with a new method to do it. So she had a lot going on in her brain and she always knew so much. One of the biggest missions that she helped was the Friendship 7 mission. John Glenn was the astronaut for this, and he went into the Friendship 7 capsule, and this was one of the first times a man was going to fly an orbital flight around the Earth. Katherine Johnson did a great deal of the calculations for this as well. And John Glenn, the morning that they were going to launch, said he didn't trust the IBM computer machine that they had used, basically an earlier version of the computer that they had. He didn't trust the numbers that had put through. He said, I trust Katherine Johnson's numbers, and if she says I'm good to go, then I'm good to go. And I just admire Katherine Johnson so much in this situation because all of the pressure was on her, and she delivered, and they rescued John Glenn safely from the exact coordinates that she had calculated, and John Glenn put his life in her hands and in her math, and she delivered. Another person that I've always admired a lot is my Grandpa Bill, right here. This is when we went and visited him over the summer for his 90th birthday. I went to him with the San Diego Air and Space Museum, and they had a rocket there that looked very similar to this one. He started explaining to me from his rocket scientist years when he worked for Aerojet how this rocket worked. He said that the two white rocket boosters on the outside give about 1 million pounds of thrust each, and the entire rocket weighs 2 million pounds. So the only job of these two boosters is to get the rocket off of the ground, and then the orange rocket carries it the rest of the way and gets it into space. And hearing him talk about this at 90 years old and still being so sharp just lit off the spark in my soul, and I just got so excited about it. And ever since then, I've just loved hearing more and more about it and just finding out more ways that rocket works, from starting off with what he had to say. Another very interesting thing about space travel is that it's constantly advancing. I'm sure you've heard of SpaceX, which was created by Elon Musk, and it's one of those big names right up there next to NASA. One of the rockets that Elon Musk made was the Falcon 9 rocket. He built this rocket at a cost of $440 million, which is a third of what it would have cost at NASA. He's efficient. He knows how to get stuff done and quick. He also built the Dragon spacecraft, which has escape rockets like any other rocket, but this specific model is going back to an earlier model of rocket, which is an upright model, and he puts the escape rockets down at the bottom near the rocket boosters, and this model actually makes it so that the materials used in the rocket are reusable. And most of the time, rocket materials are burned up in the atmosphere or just eroded in space travel, but he's made it so that they can be reusable, which is groundbreaking and amazing. So if we look back on the history of rockets, the first rocket was launched in 1942, and the first rocket launched successfully into space was in 1957. That's only 9 years older than my parents. So this is a very new idea, and because of that, it's constantly evolving, and it's pushing calculus, physics, geometry, engineering, architecture. It's pushing all of it to the limits. And because of that, I find it extremely interesting, so much so that I actually changed my major to engineering so that I might be able to do something with aerospace engineering in the future. So, if you ever see me working for NASA or SpaceX, hopefully, just know that not everyone can pull off a spacesuit, but I'm gonna rock it.